We have previously studied linear motion, or going from one place to another. Now we are going to study repetitive motion, which can be either oscillation or vibrations. We are going to focus only on periodic motion, which is motion that is repeated in a constant cycle. For example, here we have a pendulum. This is one of the basic examples of periodic motion. Why? Because it goes back and forth in the same cycle over and over again in the same amount of time. Now, there are different elements to periodic motions. The first one we are going to be talking about is position. The original position, is called the resting position. This is the position the object is when there is no force exerting over it. Now, when we move it, it gets to a highest point, goes back, and then goes on the other side in the same distance. This distance that goes from the resting point to the highest point is called amplitude, and it's the same on both sides. Amplitude here, from here to here, this distance is the amplitude. The next concept is the period. The period is the amount of time it takes to make a full cycle. A full cycle is starting from the resting point, going back and forth, and returning to the resting point. All that movement is called one cycle. It's one cycle, two cycles, three cycles. Okay? The amount of time it takes to complete one of these cycles, this is our period, and it's represented with the letter T, uppercase T. Next we have frequency. Frequency is the inverse of period. And what is that? It means that period is the amount of time it takes to complete one cycle, while frequency is the amount of cycles that we can complete in 1 second. Okay? Let's say we can do these 3 cycles in 1 second. That means that our frequency is 3 cycles per second, or 3 hertz. Hertz is the unit to measure frequency. Now, what causes periodic motion? As we all know, we have the force of gravity. In this case, for the pendulum, we have the force of gravity acting upon it, trying to return it to the lowest position. We pull it back and it tries to go to the resting position. But since we also have inertia, meaning that if the object is moving, it will continue to move until another force is exerted on it. Okay, so we release it and it will go back to the resting position because of gravity, and because of inertia it will continue again until the highest point, until gravity is greater than the inertia. Then we'll go back, and that is what makes the cycle. This force of gravity that is trying to make it go back to the resting position, specifically for periodic motion, is called restoring force. It is trying to restore its position to the starting point, or the resting position. That's why it's called restoring force. Okay? You can also feel the restoring force in other kinds of periodic motion. For example, if you have a guitar and you try to pull one of the strings, you will feel the force trying to pull it back. That is the restoring force. Now, what factors affect periodic motion? We have mass. You know, if we had a heavier object in here, the motion would be slower. There is also the damping. The damping is, as you can see, the amplitude starts to be smaller and smaller with each cycle. Why? Because, as you all know it, we are surrounded by air, and air causes friction, which is stopping the motion. Okay, so each time we get a slowing rate, that is damping, the slowing down of the motion. And we also have resonance. Resonance is the opposite of damping. That is, if we are exerting an outside force, if I start to push and push and push, each time the cycle will be greater. Okay? Like, for example, when you are on the swings and someone is pushing you, the amplitude starts becoming greater and greater each time because you are exerting a force. That is the resonance, when the amplitude gets bigger. Damping is the opposite, when the amplitude is starting to get smaller. And that is it for our class of periodic motion. If you have any questions, don't forget to log in for the Facebook Live Q&A. And I hope you have a nice day. Bye-bye.